equations number 8. Today we're going to look at the first part of learning target 2, which is all about the substitution method. So where I'm going to teach you the substitution method so we can solve a system of linear equations, and we're actually going to solve it algebraically. So I just wanted to go over what is this substitution method I was talking about. So I just wrote an equation. If you want to find room on your papers to write this, totally fine. Otherwise, you can always refer back to this video again about what substitution method is. So substitution, just like it sounds, it's kind of like when we check our answers, when we solve equations, we substitute what we think is the value in for x back in for the x, and we solve to see if it works. So just like we substitute to check answers, it's a way to algebraically solve a system of equations. And we are going to use it by substituting one value of y in for another. So usually we go y, but we can also go x. So I have 4 steps that I usually go through. So first, I'm going to substitute the y equals or the x expression into the other equation and solve for that missing variable. And then step 2, we're going to substitute your answer from the equation you did not substitute with step 1 and solve for the other variable. And then the solution is an order pair. So you're going to write down the order pair, and then we're going to check our solution. So let's get started, and we're going to kind of follow those steps. So if you wrote them down, then you can kind of watch as I follow those steps and how we're going to use the substitution method to solve a system of equations. So system of equations, I'm going to put a bracket around here. System of equations are going to be 2 or more equations that use the same variables. So the variables used here are x and y. And so we are going to solve using the substitution method and figure out which value of x in both these equations and what value of y in both these equations make both the equations true or satisfy both equations. So I'm going to start. And what I notice is that I already have what I would say you're going to isolate one of the variables. So if you look, I can see the y is already equal to 4x plus 6. Again, y is equivalent to or equal to 4x plus 6. So I can substitute y in for 4x plus 6, or I can substitute 4x plus 6 in for y because they're equivalent. It's like a sports team. You're going to substitute one player for the other. So you're going to substitute George in for Elmer, and Elmer is going to come out, sit on the bench, and George is going to go play in for Elmer. So it's a substitution idea. So I'm going to substitute 4x plus 6 in for y. So I'm going to take this y out right here, and I'm going to put in the expression of 4x plus 6. So I'm going to rewrite this. I'm going to rewrite it with this equation because I'm using this top equation to use this substitution. And I'm going to go negative 7x plus, and notice I'm going to substitute that y out. I don't want the y. 4x plus 6 equals negative 6. And why you're going to substitute is because when you go to solve, you can only solve with one variable at one time. So you can't really solve the top one or the bottom one because it has 2 unknowns. So we're going to use the substitute method to take out that y so we can substitute that 4x plus 6 in there. Now if you look at it, we have all x's. And now we can solve this problem like we normally have. I'm going to combine like terms. So negative 7x plus 4x is a negative 3x plus the 6 equals negative 6. And now I'm going to go through my steps. I'm going to subtract 6 from both sides. I get negative 3x equals negative 12. And now I'm going to divide by negative 3. And I get x to equal 4. So step 1, I substituted. And now I got the variable for 1. Now I'm going to go back in and I'm going to solve for the other variable because I need to know both the x and the y. So now I know the y. I'm going to use that first equation, the one I did not substitute into. So I have y equals 4x plus 6. And now I know that x is 4. So I can, again, substitute the 4 in for x and solve. So 4 times 4 is 16. Add a 6 is 22. So now I know what the x value and the y value is that satisfies both these equations. And I write it as an ordered pair. That'd be the third step. So 4, 22. So if I was graphing this, this would be the point of intersection. This is where both of those linear or straight lines, the two straight lines, would cross. Now I'm going to check. Put a little thing here. So to check, you're just going to plug them back in to make sure it works. Remember, this is your x value and this is your y value. So I'll take the first equation. So y is 22. So 22 equals 4 times 4 plus 6. Again, 4 times 4 is 16 plus 6 is 22. So I get 22 equals 22. Perfect. You got to check it with both equations because it has to satisfy both. So I have -7. I said the x over here is 4. And I'm going to add that. Remember, I'll take this out. That was a y. So I'm going to add that to my y value, which now I think is 22. And hopefully it equals a -6. So -7 times 4 is -28. Add the 22. Check it again. -28 plus 22 is -6. And they both equal -6. So I know that this right here is my solution. That's the answer. That's the x and y values that satisfy both. Okay. Next problem. Put the bracket around. So this is my system of equations. Notice they both have x, they both have y. I can't solve it the way it is because you can't solve two unknowns. So I'm going to do the substitution method. So my substitution method again is this expression right here, -3/4 x plus a -1/2 x is equal to y. They're the same thing. So I can take one out, plug in the other. So I'm going to look at the other problem, the other equation, and I'm going to, instead of this y here, I'm going to substitute -3/4 x plus -1/2 y. So when I do that, it will look like -3/4 x plus a -1/2 equals, because I've been the y right here, and it now still equals -1x minus 1. And we're going to go ahead and solve. I'm going to take care of the x's first. Since this one's smaller, I'm going to add 1x to both sides. I get 1/4 of an x plus 1/1/2 equals -1. I'm going to add a half. That's negative. So I get 1/4 of an x equals -1/2. And then I'm going to divide by a fourth. And I get x to equal, well, -1/2 divided by 1/4 would be a -2. So my x equals -2. Now I'm going to go back and substitute. This would be your second step. So I'm going to substitute back into the equation I didn't substitute into, which would have been this one. So I'm going to solve for y, because I already know my x. I'm going to take this equation. I know now a new x. I believe it's -2. We're going to add -1/2. So y equals -3/4 times -2 equals, well, that would be 6/4 plus a -1/2. So if I go through the math there, so that would be -2. That's equivalent, because when you add, you have to have them the same. So 6 plus a -2 is 4. So that's 4/4, or other known as 1. So now I know the x value, I know the y value, I have a solution, -2, 1. So again, if I were to graph these two lines, I'd graph this line and I'd graph this line, they would intersect at -2, 1. Let's make sure that we're actually right by checking. So take the top one. So instead of a y here, we're going to plug in the y of 1, because that's what we believe it is. So that equals -3/4. That x, now we believe, is -2. And we're going to add a -1/2. And I honestly just did this. In the step over here, we got 6/4. You add that to 1/2, -1/2, and you will get 1. So the first one checks. Now we'll check the second one. So we think the y is 1. It equals -1. We think the x is -2. And we're going to subtract 1. So -1 times -2 is 2. Subtract 1 is 1. So they both check. So I both know that I guarantee that is the solution. That is the only point, because it's one solution. This is the only point that would satisfy both of those equations in that system. Third example. So notice we both have x, both have y's. We're going to use that substitution method. Now this one, I'm going to pick the bottom number to substitute because notice that the y is by itself. So y is the same thing as 2x minus 4. So instead of putting this y here, I don't want this y, I'm going to substitute that in. So we'll write that. So we have 6x minus 3. And instead of that y, I'm substituting 2x minus 4 because those are equivalent, and that equals 3. I'm going to go ahead and solve. I have 6x. -3 times 2 is a -6x. -3 times a -4 is 12, a positive 12. I'm going to look at it again, and I notice, well, this one's different. I notice that if I put those two together, if I take 6 x's and I take away 6 x's, that's going to leave me with nothing. 0 x's, they're gone. So I really truly end up, because these cancel out, with 12 equals 3. So if I step back and look at that and analyze it, I'm thinking 12 equals 3? Well, that's not true. So if this statement is not true, if you end up canceling out the x values, then you know there is no solution, because there is nothing that equaled to both sides. The other way I could show it to you, I'll go back up here. So we'll start this step. 6x minus 6x plus 12 equals 3. So we can go back into what we looked at in EE7 in the last learning target. And if I would add 6x to both sides, then I end up with 6x on this side plus 12. I end up with 6x plus 3 over here. And if we remember back then, if the coefficients are the same, in this case they're both 6, but the constants are different, we know it's no solution. So that's another way to look at it, is you can move one of those variables over to the other side and notice that they're both the same and they have different constants, so we know it's no solution. Example number 4. So our system of equations, put in my bracket there, is y equals 2x minus 4 and y equals 2 times x minus 2. So I'm going to substitute, since y is equivalent to or equal to 2x minus 4, I'm going to substitute that in for this y so we can solve for x. So again, I'm going to take out this y and I'm going to substitute 2x minus 4 in for that y, since y is equivalent to the 2x minus 4. So my new equation will be 2x minus 4 equals 2 times x minus 2. This side's already simplified, so I'm going to work on the distributive property. So I'm going to take 2 times x, 2 times -2, which is -4. So I have 2x minus 4. I'll drag down from the left side. That equals 2x minus 4. And I know from last EE7, the last unit there, that we know if they have the exact same coefficients and the exact same constants, I have an infinite solutions. Enjoy substitution.